All right. Hi, Algebra 2 students. This is Miss List. I'm just going to go over another level 2 problem so that you have another example if you need any help or something to kind of guide you as you go through your summative project problem. So you can see I have my polynomial written up on top here in blue. So my polynomial in standard form is x to the fifth minus 7x to the fourth plus 17x to the third minus 47x squared plus 72x plus 144. And I'm just going to go through the template so you can kind of get an idea of another example. Use this to kind of help you as you go through your template with your own polynomial. So starting with end behavior, looking at my polynomial is odd. How do I know this? Because the degree, remember the degree is the biggest exponent, is 5, and 5 is an odd number. Okay, so we always go based on our degree. Biggest exponent determines whether it's even or odd. And then looking at my leading coefficient, remember when you don't have a number out front, there's like an imaginary 1, and that 1 is positive. So my end behavior is also going to be positive. And again, I know this because my leading coefficient is a positive 1. All right, so I can use that knowledge then to be able to describe my right and left end behavior. Okay, so remember, end behavior always started with what I call sentence starters. So describe the right end behavior. It's saying as x goes to positive infinity, what is our function doing? And then describing our left end behavior, that's the left side of the graph. So as x approaches negative infinity, what is our function doing? Okay. Remember, our goal is always to kind of finish these, what is happening with the graph. Okay. So looking at our end behavior, odd, positive, you do have notes on this, so you can always go back to this. I'm just going to make a couple of notes down here at the bottom. For me, I always remember that odd is opposite. So I know that one end is going to go up and one end is going to go down. And that here, opposite. And then it's positive. So positive means that it has to look like it's going uphill. Just like if you had a positive slope on a line, it looks like it's going uphill. Your graph should look like it's going up as you read it left to right. Okay. So I'm just going to say up. So I would have a graph that looks something like this. I don't exactly know where the curves are, but I know that my right side has to go up and my left side has to go down. Okay. So that helps me fill out my end behavior then. So on the right side, if I look at my right side, my right half of my graph is going up. So the function's approaching positive infinity. And the left half of my graph is going down. So that's approaching negative infinity. All right. From here then, I'm going to move on to part 2, which is graphing our polynomial and identifying any of the integer x-intercepts that I can find. So I'm going to use Desmos to graph my function. So I'm just going to open a new tab, type in the function exactly as I was given. So I have x to the fifth minus 7x to the fourth plus 17x to the third minus 47x squared plus 72x plus 144. Okay, and you can see that we kind of have what looks like a polynomial function, but we don't have a very good visual of what it looks like. So there's a couple of ways that you can do this. You can zoom in on your Chromebook and you can zoom in your X and your Y's. or zoom out either way. You just have to be careful because we don't really want to zoom out our x's. It's really the y's that are kind of the ones that we have to change. You can also go to your little wrench on the top right here and change your window down here for your x and y axis. So I'm actually going to keep my x-axis from -10 to +10. But for my y-axis, I know my y-intercept is 144. So I'm going to make sure that that fits in. So I'm just going to go from -200 to 200 and kind of see what that graph looks like and go from there. So when I do that, you see that I do have a much better looking graph, and I'm just going to kind of click and move it around so it's a little bit more centered, but I have a much better idea of what my graph looks like. Okay, so I'm just going to take a screenshot here because they do want us to insert it. Okay, and again, however you want to insert it, I'm going to go down here to add media from my computer. And here is my graph that I'm going to drop in. I can zoom in on it so it's just a little bit bigger and I can kind of read it and look at it. All right, so from here, I'm able to answer my questions. So it starts with my integer x-intercepts. They want me to label as an ordered pair. So looking at my graph, looks like it crosses right here and right here. Just be very careful on how it's counting. So it looks like this would be 1 and this would be 3. So just be aware of how, you know, your graph is kind of counting depending on how you zoom in or out. Might change your scale. So I know it crosses at 4. So the ordered pair 4, 0. And then this would be -1. So it also crosses at -1, 0. And you have your Desmos graph open, so you can always double check it. Remember, if you tap on it, it will tell you your y-intercepts, give you the nice ordered pair. So you can see, again, it crosses at -1 and +4. All right. From here, then we're going to talk about its multiplicity. Okay. So for its multiplicity, remember, we talked about this in class last time. If it goes through the point where it crosses through the x-axis, it's a single root, or it has a multiplicity of 1. And if it has a bounce at that point, it's going to have a multiplicity of 2 or be a double root. So looking at my graph, it crosses through at -1, and that is a single. And it also crosses at 4, and we're going to call that a double, okay? Or it has a multiplicity of 2. Meaning that the value of 4 is a 0 twice. The x minus 4 as a factor is counting 2 times in order to get this polynomial broken down. So then in step 3, they want us to use our x-intercepts to write the factors of the equation. Okay, so I know I have x minus 1 or x equaling -1 as a root, which means the factor would be the opposite. So x plus 1. And that's a single root, so it's just going to stay. You could put a little exponent of 1 out there if you wanted to. And then I have 4 as a root, so x minus 4 would be a factor. And this is a double, so this is going to have an exponent of 2. Or you could always write it as x plus 1 times x minus 4 times x minus 4. So you kind of get that visual of that 4, that root of 4 is being counted twice within this problem. All right. Part 3 then is going to have me use those roots to help me break down my polynomial by either dividing or factoring to get all of the factors. Okay, so I'm just going to list the zeros or the roots that I have. So I have x equaling 4, and I'm going to list that twice because it has a multiplicity of 2. So I'm going to be able to divide that twice. And then I also have x equaling -1. So those are the 3 that I'm going to start with. And we'll kind of see what happens as we go through. So I'm going to set up synthetic division. If you prefer long division or the division using the area model, you can still do it that way. Feel free, whatever you feel comfortable with. Just know that I'm going to use synthetic division for this example. So I'm going to set it up. I'm going to put 4 in the box, and then I'm going to list the coefficients of my original polynomial. So the one from way back in the beginning or the one that I graphed. So I had 1, -7, 17, -47, 72, and 144. Okay, and I'm just going to remind myself that this is degree 5, which means when I get my answer, this is going to be degree 4. Right, my answer is always 1 degree less than what we started with. So I'm just going to go through, bring down my first term, and then I multiply, add until I run out of terms. Feel free to have a calculator kind of nearby. Some of the numbers might get a little big to do in your head, so no reason not to use a calculator. So 1 times 4 gives me 4. Add straight down, I get -3. -3 times 4 is -12. Add straight down, I get 5. 5 times 4 is 20. And when I add straight down, I get -27. 4 times -27 gives me a -108. And when I add that to 72, I get a -36. And finally, -36 times 4 gives me a -144. And I have no remainder, okay? Which is what I want. It shouldn't have a remainder. Remember, we're plugging in, we're dividing by something we know is a root. So it should work, it should divide in nicely and not have a remainder. All right, so this answer is degree 4. Now, normally I would go, okay, well, we'll factor or we'll use quadratic formula to keep breaking it down. Unfortunately, it's degree 4, so I'm not ready to use quadratic formula, and I don't know how to factor something that's degree 4. So I need to set up synthetic division again, okay? Now I've already used the root of 4 once, but I can do it again, okay? So I'm gonna set up synthetic division again, and I'm gonna use my other 4. You could use the -1. It doesn't matter what order you go in, you'll get the same answer. But just make sure you start with the new answer. Okay, we don't want to go back to the original because that won't help us. So using the answer that I just got for my first synthetic division, I'm going to set it up and do synthetic division again, okay? And again, this answer was a degree 4, so my new answer is going to be degree 3. I just like to write myself a little note so that I know what my final answer will look like. All right, so bring down the first term. 4 times 1 is 4. Add straight down, I get 1. 1 times 4 is 4. Add straight down, I get 9. 9 times 4 is 36. -27 plus 36 gives me 9. And 9 times 4 is 36 again. And again, I have no remainder. Okay. Now again, this is degree 3. So I have x to the 3rd plus x squared plus 9x plus 9. And unfortunately, I still can't factor or use quadratic formula because I'm still left with something x to the 3rd. So I need to do synthetic division one last time. Okay, and this time I'm going to use my last root that I know, which is -1. And I'm just going to set it up over to the side here. And again, I'm using my answer from the previous problem. Okay, don't ever go back to the original. And again, it doesn't matter the order. If you started your synthetic division with the -1, you'll get the same answer in the end. And I'm just going to remind myself that this answer is going to be a degree 2 because it's going to be one less than what I started with. So I'm going to bring down my 1. 1 times -1 is -1. Add straight down, I get 0. 0 times -1 is 0. Add straight down, I get 9. And then 9 times -1 is -9. And again, I get a remainder of 0. So what I have left, again, degree 2 is 1x squared, or just x squared, plus 0x plus 9, which is really just x squared plus 9. Okay, so I used all of the roots that I knew. I knew that it had a root of 4 twice. It was a double root, so I was able to do synthetic division twice. And that other root of -1, that was a single root. And I was able to use synthetic division and keep breaking my polynomial down into smaller and smaller factors of it. Okay, and so that's part 5, is to now actually write out our factors, or write out our polynomial in factored form. So that's not only using what we got here, but also the factors that we listed from the first part. Okay, so factored form for this polynomial, we would say is x plus 1. And that again had a multiplicity of 1, so it's just going to stay, times x minus 4, which had a double root or a multiplicity of 2, so that's going to have an exponent of 2. And then this final factor that I found after I broke it down using those ones that I knew, x squared plus 9. Okay, so this is factored form. If I multiplied this all back out, I would get the original polynomial that I started with at the top. And then my final step is to find all of the roots, both real and complex. So we already found a couple of these. Again, I'm just going to rewrite this, x plus 1. And then remember, this is just saying x minus 4 times x minus 4 times x squared plus 9. So if I set each factor equal to 0 and solve, I'll be able to find my roots. So x plus 1 equals 0. Subtract, and I have a root at x equaling negative 1. X minus 4 equaling 0. I'm going to have a root at x equaling 4. I'm not going to do it again because I know it's going to just be 4 again. I already know that it has a multiplicity of 2 or a double root. We already talked about that. So I know 4 is a root. And then if I solve the last one, x squared plus 9 equals 0, I'm going to subtract 9. And I get x squared equaling negative 9. And this is where our imaginary solutions come in. So when I square root, I get x equaling plus or minus square root of negative 9. If you know how to simplify that in your head, that's fantastic. Go ahead and do it. Otherwise, remember, we can break this down to be saying the square root of 9 times the square root of negative 1. Square root of 9 is 3. Square root of negative 1 is I. So this is really saying x equals plus or minus 3i. Or we could write them separate, x equals 3i and x equals negative 3i. And we can see that we have 4 roots, negative 1, 4, 3i, and negative 3i. We were only able to see 2 of them on our graph because those were the real ones. But with all of our breaking it down, we were able to find that it had imaginary roots as well. Below this is just the rubric for your summative grading. So you have an idea of what you're going to get graded on. Hopefully this helps. If you have any questions while you're working on your problem, don't hesitate to ask your teacher.